Okay, this problem is a common emitter transistor, and it has these values, so 12 volts for a supply voltage, gain of 100, R1 is 20K, and R2 is 3.6K. My RC is 1.2K, and my RE is 220 ohms. And this input signal is 3 kilohertz, 1 volt peak-to-peak signal. So I need to label my emitter, collector, and base. So this is my collector, this is my base, this is my emitter. What kind of transistor? It's an NPN transistor, right? Because the arrow points out and it's on the emitter. On the circuit figure, label where the output voltage is measured. So for a common emitter transistor circuit, the output voltage is here on the collector. So this is my V out. This is an amplifier circuit. My last circuit was a follower circuit. This is an amplifier, so I should be able to get output signals that are bigger than my input signal, and I'm comparing that to my AC input and output signal. On the circuit figure, label where the output is, so we got that. Calculate the values necessary to draw the load line and add the load line to the graph. And we have to draw the models that go with each. Okay, so the models are, this is cutoff. So again, what we're doing is we're replacing our collector to emitter circuit here with either an open or a wire. So this is my VS for my V source. I've got a resistor, that's my RC. I've got another resistor, that's my RE. And I actually want an open between here. So this is my C, and this is my E. And this is a ground. Not sure why my RE is there. We'll get rid of that. Okay, so looking at this, my VCE, my VCE is just going to be my VC minus VE. And that's equal to 15 volts minus 0 volts. So notice 15 volts because C is connected to VS and there's no connection between C and E, so no current can flow. So I don't have a voltage drop across here. I can't because there's nowhere for the current to flow, so there's no voltage drop. So that means my VCE in cutoff is going to equal, and then I said 15 volts. Well, let's just check. It's 12 volts. So this is going to be 12 volts here. And so this VCE is in cutoff is going to be 12 volts, and my IC in cutoff is going to equal 0 amps. And now in saturation, I'm going to have my resistor. This is my C. It's going to be connected with a wire. This is my emitter resistor, and ground. So this is my RC, this is my RE. This is my RE, my RC. So I noticed between VC, for VCE, VC is equal to the same value as VE. So when I subtract these, I'm going to get 0 because there's no voltage drop between them. They're both connected to the same point. So there's going to be some value for VCE here, some value for VC, and the same value for VE. So I just know this is going to be 0 volts. But what about the current? What about IC? So this is going to be the maximum value for current that I can have because I've replaced the transistor connection of collector to emitter with just a wire. So it's the max current I can have. So that's going to equal to VS. So VS represents the source voltage, just like VCC represents the source voltage. You can use either one. So I'm going to have RC plus RE. And so then IC is going to equal 12 volts divided by my resistors are RC is 1.2 and RE is 220. So I'm going to add these two together. So I'm going to have 1,420 ohms. And so for, did I write that? I don't know that I did, so let me just pull up my calculator. So 12 divided by 1420 equals 8.5. So I have IC equals 8.5 milliamps. And so that's my max value that I can have. So if I go over here, I don't have a good graph here. So let me pause this for a moment.